Hey there! We're about to dive into one of the most powerful yet kind of invisible forces that protects our entire digital world, cryptography. It's the silent guardian of pretty much everything we do online, and we're about to pull back the curtain on how it all works.
I mean, really think about it for a second. Every single time you send a private message or log into an app or, buy something online, you're basically putting your trust in the system. You just assume that your information is safe from prying eyes. So what is it that's actually standing guard?
Well, that guard, that's cryptography. And honestly, the best way to picture it is as this powerful and visible shield. It stands between your sensitive data and anyone who might want to snatch it. So today, let's figure out how that shield is actually built.
So how is this shield built? Well, it all comes down to a fascinating field known as the science of secrecy. And at its heart, it's a really simple idea. How do you turn your personal data into a secret code that absolutely no one else can read?
The core concept here is surprisingly straightforward. You start with something readable, like an email or your password. That's called plain text. Then, cryptography does its thing, scrambling it into what looks like total nonsense. And that scrambled up version, that's what we call ciphertext.
Let's break it down. It really happens in 3 simple steps. First, you've got your private message, the plain text. Second, a process called encryption locks it up tight using a special digital key. And finally, what comes out on the other side is the ciphertext, totally scrambled, unreadable, and most importantly, secure.
And that's the whole point, right? It all comes down to the key. A hacker could totally intercept that scrambled message, but without that one specific key that was used to lock it, it's completely useless to them. It's just a bunch of digital noise. The key is everything.
Okay, so we've established the key is everything. But that brings up a really important question. If you need a key to lock and unlock the data, how do you manage that whole process securely?
Right? That's the big puzzle, isn't it? How do you get the key to the right person without an attacker grabbing it first? Well, this fundamental problem is solved by the 2 main types of cryptography. So on one hand, you've got symmetric cryptography. Just think of it like a normal house key. The same key locks the door and unlocks the door. It's super simple, but there's a big challenge. You have to share that key securely. But then you have asymmetric cryptography, which solves this with it's a brilliant twist. It uses 2 keys, a public key that you can give to literally anyone, and that's used to lock the data. But the only way to unlock it is with your private key, which you never, ever share. And this clever 2-key system is what makes so much of our digital life possible. It gives us confidentiality, making sure only the right person can read the message. And it also gives us integrity, which proves that the message wasn't messed with along the way. All right, so that's the theory. Kind of cool, right? But this isn't just some abstract science class stuff. Let's look at where you actually see this digital shield in action every single day, probably without even realizing it. Honestly, you use this stuff constantly. You know that little padlock icon in your browser? That's HTTPS, and it's using cryptography to secure your connection to that website. If your laptop ever gets stolen, full disk encryption, things like BitLocker or FileVault, makes all your files completely unreadable. Oh, and when you create a password for a service, they use a special one-way process called hashing to scramble it so that not even their own employees can see what your password is.
Now, for your data to be really, truly safe, it needs protection in 2 different states. First is in transit. That's like an email flying across the internet. That's where HTTPS is the hero. And second is at rest. That's for files just sitting on your computer. That's what full disk encryption is for. You need both to have a complete shield.
So, after all that, what's the big takeaway here? It's that these incredibly powerful tools aren't just for governments or giant corporations. They give you the power to build your very own digital fortress. And this quote just nails the scale of modern protection. When it's done right, strong cryptography creates a digital fortress that even the world's most powerful computers would take lifetimes to crack. I mean, that's a defense that is, for all practical purposes, unbreakable with the technology we have today.
At the end of the day, it doesn't matter if you're just one person or a massive company. Properly using these tools, from HTTPS to file encryption, is the single most effective defense we have against the constant threat of data breaches. It's just that simple.
So I'll leave you with this one question. You've seen the shield, you know how it works now. So maybe take a moment to look at your own digital life. Are you looking for that padlock in your browser? Are your devices encrypted? How strong are the walls of your digital fortress? Thanks for tuning in.